Have you ever wondered if time travel is possible? Today we delve into this fascinating question. Time travel, a concept that has captivated our imaginations for generations, has been a staple of science fiction. From H.G. Wells' The Time Machine, to the modern-day cinematic adventures of Back to the Future and Doctor Who, the idea of journeying through time has been depicted in countless ways. Yet, is there any scientific basis for this intriguing concept? Could we, one day, actually traverse the vast expanse of time as easily as we do space? Well, the answer might lie in the mystifying world of quantum mechanics. This field of study, as peculiar as it is powerful, may hold the key to unlocking the secrets of time travel. To understand this, first we need a basic understanding of quantum mechanics. Let's dive in and explore the quantum realm, where the usual rules of reality bend and twist in the most unexpected ways. Quantum mechanics. Sounds complicated, right? But don't worry, we'll break it down. Quantum mechanics is the science of the very small. It's a branch of physics that deals with particles at the atomic and subatomic levels. Now, this isn't like your regular everyday physics. We're diving into a world where the rules of classical physics no longer apply. One of the key concepts of quantum mechanics is superposition. This is a fancy term for the idea that a quantum particle can exist in multiple states at once. Imagine, if you will, a coin spinning in the air. While it's spinning, it's neither heads nor tails, but both at the same time. It's only when the coin lands that it adopts one definite state. That's superposition for you. Next up, we have quantum entanglement. This is another mind-bending concept that tells us if two particles are entangled, the state of one particle is directly connected to the state of the other, no matter how far apart they are. Think of it like this. If you have two entangled particles and you change the state of one, the other changes instantaneously, even if it's on the other side of the universe. Yes, it's as mind-boggling as it sounds. These concepts, superposition and entanglement, break our conventional understanding of how the world works. They challenge our perceptions of reality. But that's the beauty of quantum mechanics. It's a realm where impossible becomes possible, where the strange becomes the norm. So why does any of this matter? Because these concepts are the very building blocks that just might, make time travel possible. They open up a world of possibilities, including the tantalizing concept of moving through time. With this basic understanding of quantum mechanics, we can now explore its link to time travel. Opening. How does quantum mechanics bring us closer to understanding time travel? Quantum mechanics is a branch of physics that deals with the microscopic world. It's a realm where particles can be in two places at once, can pop into and out of existence, and can even be entangled, feeling each other's effects instantaneously, no matter how far apart they are. This is the bizarre and fascinating world of quantum superposition and entanglement, concepts that are central to our understanding of time travel. In the quantum world, superposition allows particles to exist in multiple states at once. Imagine a quantum particle being both here and there, now and then, all at the same time. This is where the idea of different timelines comes into play. If a quantum particle can exist in multiple states, could it not also exist in different times? The theory goes that if we could harness the power of quantum superposition, we could potentially exist in and explore different timelines simultaneously. It's like being in a quantum choose-your-own-adventure book, where every decision leads to a new storyline, a new timeline. But let's not get ahead of ourselves. While this theory sounds fascinating, quantum mechanics is still a largely uncharted territory. We're only just beginning to understand the strange behavior of quantum particles, let alone how to manipulate them for something as complex as time travel. And then there's the question of entanglement, another quantum phenomenon where particles become intimately linked, and a change in one particle's state can instantaneously affect the other, no matter the distance. Could this concept be somehow related to time travel? We're still not sure. Closing. But what does this mean for us? Can we really time travel? The answer remains elusive. Quantum mechanics opens up a world of possibilities, but it's a world we are still trying to comprehend. We're at the beginning of a long journey, a journey that may one day uncover the secrets of time itself. The theories are fascinating, but what is the reality of time travel? In the realm of quantum mechanics, the concept of time travel is a tantalizing proposition. Yet it's important to remember that there is a stark difference between theoretical possibility and practical reality. The limitations and challenges of time travel are immense. Even though quantum mechanics allows for the possibility of time travel, it does not provide a practical method for achieving it. Quantum systems are notoriously delicate, easily disturbed by their environment. Thus, maintaining a quantum state long enough to enable time travel would require technological leaps that we cannot even imagine right now. Moreover, the quantum realm operates on a scale that is minuscule compared to our everyday experience. Quantum effects are observable primarily at the microscopic level, with particles smaller than atoms. How do we translate these tiny quantum events into a macroscopic event like time travel for a human? In addition, there's the grandfather paradox. This is a hypothetical scenario where a person travels back in time and kills their own grandfather, preventing their existence. Quantum mechanics might allow for such paradoxes, but it doesn't resolve them. The paradox illustrates the logical problems that time travel could introduce, and these have yet to be satisfactorily resolved in any theoretical framework. Lastly, there is the issue of energy. The amount of energy required to manipulate time would be astronomical. We're talking about the kind of energy produced by stars, not your typical power plant. Harnessing such energy safely and effectively is far beyond our current capabilities. Yet, despite these challenges, the exploration of time travel through quantum mechanics is not in vain. It pushes the boundaries of our understanding and forces us to reconsider our perception of reality. We are still far from making time travel a reality, but the journey of discovery is just as important as the destination itself. So, while we might not be hopping into a time machine anytime soon, the exploration of time travel through quantum mechanics gives us a whole new perspective on the nature of reality.